Okay, students, today I have defined you Fourier series expansion. Yes, Fourier series, which is defined as a series of the type 1 by 2 a naught plus sigma n varying from 1 to infinity a n cos nx plus b n sin nx, yes, is a series of a series. This is a trigonometric series where a0, yes, where a0, an and bn, yes, are constants, are coefficients, yes, are constants or coefficients yes, for n is 1, 2, 3 up to so on. Okay, and where the coefficient a0 is, we can prove this term where a0 is, this is, we have proved 1 by pi minus pi to pi f of x dx, yes, an, this is equal to 1 by pi minus pi to pi, yes, f of x cos nx dx, and also bn is equal to 1 by pi minus pi to pi f of x sin nx dx. Yes. If the coefficients a0, an and bn are derived from a function f of x, yes, then this function for the function f of x, yes, this one. For the function, then it is called a Fourier series, yes. Then the function, this one is called a Fourier series generated by the coefficient a0, an and bn. So these are the constant or the coefficients a0, an, bn are called Fourier coefficients. Yes, okay. Now we prove these constants. Okay. We can prove this constant. We use some well-known results. Okay. From definite integral, we know that, yes, we know that, yes, from definite integral, we know that some results, yes, minus pi to pi sin nx dx is equal to minus pi to pi cos nx dx is equal to 0. That equation number 1. And similarly, minus pi to pi sin mx cos nx dx is equal to 0, equation number 2. And similarly, minus pi to pi sin mx, yes, sin mx and sin nx, this dx is equal to 0 if m is not equal to n, and this is equal to pi if m is equal to n. Yes, and also we get this can be also be defined as minus pi to pi cos, yes, or you can say the sin mx, this can be written as, and cos nx dx, this is equal to 0 if m is not equal to n, and which is equal to pi if, yes, if m is equal to n. Yes, third identity and this one fourth identity. Okay, where m and n are positive, yes, positive integers. Yes, clear? This is the Fourier series. Now we prove that now for the Fourier series we use these identities. Okay, to prove this first one, let us suppose that this is a0, an and bn by using this. So from the equation number 1, or you can that let us suppose that this is a, yes, this is b, or you a1, a2, let us, this is a3. Yes, now to prove this, the integrating the equation number a, yes, to find out the constant of a0, yes, to find, yes, coefficient a0, a0, yes, we integrate term by term, we integrate equation a term by term from, yes, term by term from minus pi to, yes, from minus pi to pi. Okay, in equation number 1, which is given as f of a is given as f of x is equal to half a naught, yes, plus sigma n varying from 1 to infinity a n cos nx plus b n sin nx. Yes, from this equation. Okay, now from this equation, this is the equation, here you have defined where is a, yes, which is the kind. Now integrating term by term, if you integrating, that is operating integration on both sides, yes, integrating this one, that is minus pi to pi, yes, f of x dx, yes, here is again half minus pi to pi, okay, and a0, yes, dx, clear, plus here is again minus pi to pi, and the summation is n is 1 to infinity a n cos nx plus b n sin nx, and this whole multiplied by dx. Yes, I think you have clear integrating this series from minus to pi. Now you see here in this result, you see here this one minus this one, here is a cos nx, n is a coefficient, or you can say constant, a cos nx minus pi to pi cos nx, this become according to this one minus pi to pi sin nx dx, and also minus pi to pi cos nx dx is 0, yes, so this term is, yes, 0, so you get only this term, yes, this term, that is minus pi to pi f of x dx is equal to half of, and here is a0, yes, a0 and x, yes, a0 x from minus pi to pi. Okay, integrating this one, so you get this minus pi, then you get this is equal to again pi minus minus plus pi, so this become f of x, you get this is So a0 you get 1 by here 1 by 2, here is you see, then here minus pi to pi, then you get from here is a0 is 1 by pi become here 2 to cancel out. You can see that like this. This is a0 2 1 by 2 a0, and here is also 2 pi. Yes, so 2 to cancel out, so a0 become 1 by pi of this one. Yes, or you say that this is equal to, yes, or we get a0 is equal to 1 by pi minus pi to pi f of x dx. Yes, clear? Yes. And now similarly again multiplying, yes, name again, yes, multiplying, now multiplying equation A, yes, by cos nx and integrating term by term and taking the limit from minus pi to pi and integrating, yes, from minus pi to pi. Yes, clear? And now you see again f of x, you see here f of x, here you multiply cos nx, here multiply, and also here multiply. Okay, so if you multiply, we have here write it f of x, yes, this is equal to, here is again we have write it a0 plus sigma n is 1 to infinity a n cos nx plus bn sin nx. Yes, now here you multiply cos nx on both sides. Yes, so here is also cos nx, yes, f of x, yes, minus pi to pi dx. Clear? Half, here is again a0, now minus pi to pi, yes, cos nx dx. Yes, clear? Plus here is again the limit, here is minus pi to pi, yes, cos nx, and again the summation n is 1 to infinity a n cos nx plus bn sin nx. Okay, now here you see from using the well-known results, minus pi to pi, this become 0 and this become cos nx and cos nx. Yes, this term. So this term you get from here, you see that you get a n, yes, n is equal to, this one become pi, yes, by using the well-known results, these results. Cos mx sin nx, this is equal to pi for m is not is equal to n, and this is 0 for m is not equal to n. Yes, so for using this property you get a n, yes, this is 0, so you get from here, this is again 0, so you get a n is equal to 1 by pi, pi is here, minus pi to pi, yes, f of x cos nx dx. You have cleared it? Okay. You get an, you get similarly a0 you get, and similarly you get. And now also for the next term for bn, yes, also multiplying Yes, equation A, again, equation A is here, right? Yes, so next time I am using this equation. Okay, so from this equation, multiplying equation A by sine nx and integrating yes, from minus pi to pi. Again, yes, we get, here you see, here you feel next time multiply you sine, yes. So this is minus pi to pi f of x, yes, sine nx dx, and here is again 1 by 2 a0 and minus pi, sorry, here is minus pi to pi sine nx dx, and plus here is minus pi to pi sine nx, yes, and also the summation n is 1 to infinity a n cos nx plus b n sine nx dx. It's clear. Now further using the properties of these identities. Okay, this is equal to 0, for this is equal to 5. So if you using this one, this term again you get 0. So you get bn. Yes, this term you get because sin n, so this is pi. So 1 by pi. So bn is equal to 1 by pi. Here is again pi. So you substituting pi minus pi to pi. Yes, f of x sin nx. Sin nx dx. Okay. Yes, this one you have also proved. Okay. Therefore, the series, so you can say that, okay, so you can say that the series, this one, the series A with the coefficient this as sine, cos, and for the periodic functions, this is called a Fourier series, where the coefficient A0, AN, BN are the Fourier coefficients. Yes, I think you have the clear definition of Fourier series. Okay, next time I have defined you Fourier series of the for other functions, odd or even functions. Okay, students, thank you. Yes.